This topic is about spanning trees. So in this video, I'll explain you what does it mean by spanning tree and what does it mean by minimum cost spanning tree. Then further, we have the topics like Prim's algorithm for finding minimum cost spanning tree and Kruskal's algorithm for finding minimum cost spanning tree. We will study this in next videos. So in this video, let us understand what is spanning tree. Spanning tree is a subgraph of a graph having all vertices of a graph. Like here I have four vertices, all four vertices, but n minus 1 edges, means the number of vertices minus 1 edges, so that there is no cycle formed by those edges and graph must be connected. So I'll define it formally. Like this is a graph, G is VE, G is equals to VE, and this is the number of vertices, we call it as N, and this is the number of edges, we call it as E. Now what is a spanning tree? Spanning tree, if I say S is the spanning tree, then it is a subgraph of a graph. We can find a spanning tree only if graph is connected. Then this spanning tree should have set of vertices and edges where number of vertices are same as number of this vertices and the number of edges should be equal to number of vertices minus 1. Number of vertices, total vertices minus 1. And there should not be any cycle. So this was all formal definitions. Now let us understand it in simple terms. So for this graph, I will show you what does it mean by spanning tree. This graph is having four vertices. So I must take all four vertices. Okay, four vertices are taken. Then, as there are four vertices, I should take only three edges. 1, 2, 3. Total there are 6 edges. I have taken only 3. This is a spanning tree. I'll take one more example. 1, 2, 3 and 4. I'll connect them like this. These 3 edges I have taken. Is it also a spanning tree? Yes. This is a spanning tree for this graph, and even this is also a spanning tree. So it means more than one spanning trees are possible. Yes, more than one spanning trees are possible. I will draw one more. 4 vertices I have taken. 3 edges. Yes, 1, 2, 3. Yes. Is it a spanning tree? No, it is having a cycle. It's not a spanning tree. And you can see that there is a vertex 3 which is not connected. So it should be connected and it should not have any cycle. Then we say it's a spanning tree. This is not a spanning tree. Then I'll draw a few more. See, these are also spanning trees. So various spanning trees are possible for a given graph. Can we calculate how many spanning trees are possible for a graph? Let us see. See, how many vertices are there? 4 vertices. Then how many edges are there? 6 edges. Then for 4 vertices, how many edges must be there? Just 3 edges must be there. Means 4 minus 1. So from the set of edges, that is set of edges, I should select 4 minus 1 edges. So C V minus 1. That is 4 minus 1. So in how many ways I can select? That many spanning trees are possible. So out of 6 vertices, 3 vertices can be selected in how many ways? So 6C 3 ways. So for this example graph, it is 6C 3 ways. Yes, with this I can get the answer. But let us see something. If I take like this, without labels I am showing here, this is also 3 edges, but this is forming a cycle. This is also edges, but it's forming a cycle. 2 cycles from this one. If I take this 1, 2 and 3. So this is 1, 2 and 3. This is 1, 2 and 4. Then if I take this, this will also form a cycle. Yes. And even this will form a cycle. So 1, 2, 3, 4. 4 cycles are possible. I should not take those set of edges which are forming cycles. So total 4 I could find out, right? And there are 4 cycles in this one. And those cycles are formed by 3 edges, not more than 3 edges, because we are selecting maximum 3 edges. Whatever the number of edges we are selecting, we should see that a cycle is formed using those many edges or less number of edges also. So find out all those cycles, not more than 3 edges, and subtract that one. So minus cycles. So minus 4. 20 minus 4, so this gives 16 spanning trees. So yes, for this graph, 16 spanning trees are possible. So once again I repeat, how many edges we have, then how many edges we have to select. So they can be selected in 6C3 ways for as per our example. Minus how many cycles are formed by using 3 or less edges. So out of 3 edges we found there are 4 3 cycles possible, so that 4 I have subtracted and I got 16 different spanning trees. So if I generate all, I can generate 16 different spanning trees. I have taken only 4 here, right? This was not a spanning tree. Now next thing I will explain you what does it mean by minimum cost spanning tree. So for explaining minimum cost spanning tree, I have given weights to the edges of a graph. The weight for edge from 1 to 2 is 2 and 2 to 4 is 1. So I have given the weights. Now let us understand the problem. We want a spanning tree like these such that the cost of total spanning tree must be minimum. So cost means the total weights of all the edges that are included in that spanning tree. So already I have few spanning trees. Let us give those weights to this and check what is the cost. See, this edge cost is 2 and this is 5 and this is 3. So total cost is 10 for this spanning tree. And for this one, this is 5, this is 6 and 3. So this is 14. And for this, it is 5 and this edge is 4 and this edge is 6. So this is 15. Total cost is 15. So we are getting different cost, you can see. So till here, this looks like smallest. Then this one, 2. And this is 1, this edge is 1 and this is 3, so this is 6. Oh, this is more smaller. So I did not try all 16 spanning trees, just I have taken 4 and out of these 4 I got a minimum cost spanning tree as this one. So maybe this is the minimum cost or 12 more are possible, so I should try out all of them and select the best one, right? So that's the problem. We want a minimum cost spanning tree. So there are some algorithms like Prim's algorithm and Kruskal's algorithm for finding minimum cost spanning tree that we will learn in next videos. So that's all in this video.